All right, everybody. Hello to week 11. So we are basically doing the same plots that we've done before. So last week we did a cat plot for our categorical into our categorical, and we were trying to figure out for the explanatory variables different categories was the proportion of the response variable different. And so in order to do that, we had to put some code in because the response variable was a categorical variable and it had words in there after we formatted, and we really needed to turn it into ones and zeros so that the machinery under the hood for the cat plot would get the average of those coded numbers and end up being the proportion. So this week, we don't have to do that because we want for each explanatory variable category. So we're going for an explanatory categorical and a response that's quantitative. And so for each categorical explanatory variable category, we're looking for the average of the response variables values. So we're kind of using both our categorical variables and our quantitative variables in here. So I have kind of poured it over from different weeks, getting the four variables from the code book, doing the data management, doing the formatting for my categorical variables, and then I'm ready to go. So that's all I have here before I do the code that we're doing. Notice that I don't have anything to do with ResearchPy anymore. That's taken out, but I'm heavily using Seaborn. So I've got that in here. Now I have already run this, so I made sure that my drive was connected, and I ran all and see a bunch of green check marks. And all I'm doing now is sort of explaining what the code has done and maybe play around a little bit with it. But it's done all this formatting. It's done all the data management. It's done everything that you need to do. And so here I've created a palette because I don't like the color scheme that is the default. And I put kind of a title. And so, that title shows up right here. And so what I've said is, does wearing eyeglasses, let's fix that. Does wearing glasses seem to determine how many siblings you have? And you know what? That's kind of a silly thing, honestly. If I was judging which was the explanatory and which was the response, I think it would make way more sense. Does how many siblings you have determine whether or not you wear glasses? That's a more logical thing. But the way this particular thing works is if I have a quantitative variable as my explanatory and a categorical variable as my response, then I have to collapse my quantitative variable into categories and then do a cat plot with both being categorical, which we did last week. So if really that's what makes sense to you, is to do it the other way from what I'm showing here with your variables, then you can't use that for this week. You'd have to go to your other variables. You only need one graph this week, and so the one that makes the most sense. And even if none of it makes sense, you have to pick one to just practice doing this. But for your research, if it ends up that the two variables you want to do and put together are more like mine that I have here, then you need to collapse your quantitative explanatory variable and then do a cat plot with categorical to categorical. All right, so back to how this works. You put your categorical explanatory for the X, and you also put it for the hue. So when I ran this before, I didn't put in hue, and it said, hey, this thing you're trying to do is what's called deprecated. At some point, it's not going to work anymore. And so I'm trying to do it the way that it's supposed to be done, quote unquote. So I have that X equals eyewear because it's the explanatory, and I also make it the hue. And then I put legend equals false, error bar equals none, kind equals bar, and then the other stuff that makes sense to us, y equals sibling count, so that's my response variable. Data's coming from df, okay, great. And then I said, please use this color scheme. Without this, if I take that out, and run it, it's okay, but I don't like it as well. So I have my own color scheme in there for some brighter colors. You do whatever you want, but I determined that these kind of look nice. Okay. Then I had this label, eyewear categories for my X label. I didn't rotate them. They fit just fine. And so my rotation is 0, and I don't even need this line if I don't want it. And then my Y label is the average number of siblings, because what this is saying is that people that don't wear glasses or contacts have on average 3 siblings. And it goes down. The average number of siblings goes down to the point where if you just wear contact lenses, on average only 2.5 siblings per person. And so this seems like a significant difference. It seems like there is an association, for some reason, who knows why, between the number of siblings you have and what kind of eyeglasses you wear for vision. Okay, so that's one of your graphs. And I think I said before you only need one graph. That's not true. You only need one pair of graphs because you're going to do a cat to quant cat plot. That's this one. And then you're also going to do a side-by-side box plot, similar to what we did before. But what we did before is we had either gender or race as our explanatory, and then we put our quantitative response. Well, now we're doing exactly the same thing, but we're doing it with one of our categorical variables. So I have eyewear here and sibling count as the response, doing a side-by-side box plot. Now I said show means equals true because these averages, 3, about 2.8, maybe 2.7, and then maybe 2.5, these averages are highlighted here on these diamonds. And the reason that they look so much like they're right at the same height rather than very, very different heights that they look on this graph is because this is showing all these outliers. So the scale is going from 0 to 20, whereas here the scale is just going from 0 to 3. So we see this half a person difference between neither and contact lenses. Up here it's at 3, down here 2.5. So that's only a half a person. Well, when you're going by 2.5 every tick, 0.5 doesn't look like they're very different. This is down here and this is up there, and it's hard to tell that they're at different height. But be that as it may. Okay, so I've also done asthma as my explanatory, and then number of siblings as a response. I thought it made no sense to do age diagnosed with asthma because nobody that said no is going to have even values of the age that they were diagnosed with asthma. So it made no sense, my other quantitative variable, to go against this one. So I just did number of siblings again. So I've got, a little bit of difference, and really, boy, I can't see any difference between these two. I would say that there's no association at all between the whether you diagnose with asthma and how many siblings you have. Just looking at this graph, it doesn't look like there's any difference between these two. Okay, hopefully that was helpful, and as I normally do, I'm going to go over this in class. I need to fix this comment because it's not fitting what I'm doing here. This should be sibling count, but I'll do that offline. All right, take care, everybody. Bye.